Well, I am, as you know, a geotechnical engineer, although much more than that with respect to the different disciplines that I work in. But my background is it's in engineering, it's in geotechnical engineering. And the nice thing about my career is that it's been, 50 years basically, and working in over 30 countries around the world in all different environments and different conditions. And that's been a wonderful thing for me. On a personal side, over the years, I've been a runner, a skier, things like that, and have a very happy family. So my family life has been very enjoyable as well. In high school, I decided I was going to go into engineering. I thought science would be too easy, so I said I'll be an engineer. And I liked electrical engineering, so I signed up to go into electrical engineering. But in my first year, they have a general course at UBC, which covers a number of subjects before you actually go into your discipline. And we had a geology teacher, engineering geology teacher called Dr. Kuchera. And he was an amazing teacher. He had all these different stories about different geohazards and geological acts or catastrophes or failures, and that really intrigued me. And I had a summer job doing exploration geophysics, where I was out in the field doing running geophysical surveys for a mining company. And I decided, no, I'm going to go into geological engineering. So I switched into geological engineering, and I've never looked back. Now, when I graduated, my first job was with Pete Gadsby McLeod and working on reconstruction of the flood dikes in Kamloops. And I worked there about a year doing quality control on construction of the dikes. And then I went to my boss, who at that time was John Gadsby of Pete Gadsby McLeod, and I said, I'm going to take a year off and travel. He says, what? You're going to stop engineering and travel? I said, yeah, I'm going to take a year and just go and see the world because I always wanted to travel. And then about a few months later, he says, well, do you want to go work in Nigeria? I said, yeah. And so I went for a job interview with CBA Engineering, who, by the way, is the fore company of Quippen. And I was interviewed for, it was a Canadian foreign aid project in northern Nigeria, looking at a river basin. And this river basin was probably some 250 kilometers long. It wasn't a small river basin. And I would be a team of about 8 people. And I was the dam engineer. So here I am, 2 years out of university, responsible for looking at a whole river basin, finding dams. So when I came back from there, CBA Engineering said, well, we're not very busy, but maybe Clone Leanoff at the time said, well, why don't you go for an interview with Clone Leanoff? Anyway, I was hired and went on to work first at Afton Mines and then Highland Valley and then Highland Valley Copper. At that time, it was Lornex. And I worked there for a while, and I decided, well, no, I better get a further education. So that's when I went to Imperial College and got a master's in soil mechanics. I think the interesting thing about geotechnical engineering, particularly with tailing dams, is that it's very complex. You're not dealing with construction, man-made materials. You're dealing with Mother Earth with all its uncertainty and vagaries. And no project is the same. Every project is different. There's always different conditions, different soils, different water pressures, different, you name it. And so you have the complexity of dealing with those, but also with tailing dams, you have the complexity of a lot of different disciplines. I say I'm a geotechnical engineer, but in fact, I'm a geotechnical, geological, hydrogeological, seismic, hydrological, geohazard, geomorphologist, geochemist. I mean, all those skills are what you need to know what's going on with tailing dams and be able to connect all the pieces that are necessary for the design of these facilities. So I think that's probably the biggest thing that I like, is that you're continually learning. It's never the same. I once had an engineer say to me, well, it's kind of boring now because they're all the same. And I looked at him and said, you're not looking at it deep enough then if you think all of these dams are the same, because they are all different. This was in the early 90s when Clone Leonov was struggling. There was downturn in the economy. Mining was not doing very well. And one of the main projects they had was the Ok Tedi project in Papua New Guinea. The geology in Papua New Guinea is fascinating. You get 10 meters of rainfall. You have very weak sedimentary soils that basically erode. Almost an inch a year of erosion is taken off the landscape. You have what they call the Hindenburg Wall, which was a 1,000-meter high limestone cliff. And every 400 or 500 years, the siltstone underneath it would erode and large blocks would come off. At one time, a block was something like 4 cubic kilometers. You can imagine how big a landslide of 4 cubic kilometers is. It's huge. And it created a debris torrent that went down the river and built this large floodplain, terrace deposits all along the river, and that's where the town of Tabubo lived. So we were looking for dams, tailing dams specifically, because they had a failure at the one they were building. We had this karst expert from the University of New South Wales, and she was the world president of the spelunking group. And she came to investigate karst. And I followed her once, and you go into these caves, and initially the cave is this big, and it's this big, and then it's only this round, and you're crawling on your stomach, and you're going down an incline, and you ask yourself, is this what I do when I'm a geotechnical engineer? I think as an engineer with Clone Leonov at the time, I've always thought, we shouldn't just be sitting in Vancouver doing projects in British Columbia. We should be looking at projects around the world, and we should be looking at potential offices around the world. And I know, someone said once, well, no, we can't work in Chile because we don't know the soils in Chile. And I said, well, geological processes are geological processes. They make different kinds of soils. It doesn't matter if you're in Chile or in Venezuela or in northern British Columbia. Yes, they're different geological processes, but as geotechnical engineers and with geological backgrounds, you can understand how the soils are formed and then start doing the engineering properties of them. And so when in the early 90s, I was promoted to, at that time it was called manager of mining. It became later a vice president position as manager of mining. And I thought, well, this is my opportunity to do something with the vision of what our company could be. And then so I went forward, and first we opened an office in Sudbury, chasing projects in Ontario. And so that was kind of a start in Ontario and opening the office with Inco Sudbury. And then we went to Australia in Brisbane and opened up an office in Brisbane to pursue both work in Australia and to leverage our work in Papua New Guinea. But the bigger challenge and the most interesting one was we looked at, where should we go in South America? Should we go to Mexico? Should we go to Peru? Should we go to Chile? Should we go to Brazil? And we looked at the different countries and decided, no, Peru offers the best opportunity for us to open a company or to do business. Well, I think I've been very fortunate working with KCB because we, in the 60s, Earl Clone and team took the design of tailing dams seriously. Tailing dams are really major civil engineering structures and should get the same care and attention as any other major structure, any major dam. But traditionally, tailing dams have been largely designed by civil engineers. And I think the biggest kickstarters here are failures. We've all heard about the failures, but failures actually have helped the industry progress much more rapidly than just organic change in the industry. There's no question that certainly major companies have all paid pretty good attention to tailing dams, but overall they have not had the real attention that they deserve with respect to their complexity and potential hazard to the public if something goes wrong. I think a higher level of both accountability, but also development in the industry we have to start getting trained people. We have to start designing and managing these facilities as they should be managed. So I think the biggest change I'm seeing is actually good news in that there is more acknowledgement of the complexity, more acknowledgement of what goes into the design. And I think that the future of mining, certainly mining won't go away. We always need the metals. Tailings, certainly the filtered tailings, you'll continue to see a lot more of those. I mean, we're looking at some projects now where we're looking at filtering, over 100,000 tons per day, which we wouldn't have dreamt of before. And because of the, it ties in with metal prices, obviously. When metal prices get higher because of scarcer demand, the prices go up. You can afford to spend more on your tailings and still be economic. So I think you are seeing the types of tailing dams are different, but also I think the design and construction of them to be basically lowering the risk of potential failures. We like to, our goal is always to design a facility that there's just no credible way it could fail. It might move or shift, but it's not going to fail catastrophically. And so I think the shift will be to safer tailing dams. But, there's, I think the last count, there's something like 25,000 tailing dams out there. So we are not going to get all 25,000 tailing dams up to the level that we expect. So tailing dam failures they'll still continue to happen, but we're certainly reducing the risk of major ones happening. I was very proud of that because it's a recognition that geotechnical engineering is an environmental science, and that geotechnical engineering is a huge component of the environment. I mentioned earlier that we started doing EIAs in the early 1990s and later in the 1990s. And when you think about it, we're managing a waste. And to manage a waste, you have to understand its properties. Is it a toxic material? Is it, if it's released, do you get acid generation? Are you going to have groundwater contamination if you store this waste? And so you can't design a tailings dam if you're not thinking about the environment, impact of it, the consequences of it, and understanding what happens. And so when you think about it, as engineers, we can't just block ourselves and say, no, we're only going to do the geotechnical design. It probably is tailing dams. I think I'm one of the rare few who have been working on tailing dams for basically 50 years. And I've always focused on tailing dams. And in some ways, maybe it's good that I didn't move up the corporate ladder in terms of all the management time it takes. I've been able to focus on the technical aspects of tailing dams. And my involvement with the International Commission of Large Dams and the Tailing Subcommittee has been an important part of that in terms of documenting what is good practice for understanding tailings and tailings technologies. But it was we've been working on, and it's complete now, but it's a training program with Glencore, where it's an online training program that has 3 levels. The level for technical people, which is the responsible person at the mine who has to manage engineers and look after the tailings facility. And the second level is for managers at a higher level who have to have an understanding of it. And the third level is operators who need to know, the importance of observing cracks in the dam or importance of reading piezometers or where the pond level is. But those training programs and just the mental effort of getting all the things that should be done at a tailings facility, both from design, operation, and closure. Getting those into an online training program has been, a real highlight, even though it's been extremely challenging to work through all that. Think. I think the biggest thing you can do is think, what is the problem? What am I trying to solve for my client? And when I get an answer, how do I defend that answer? And I'll have people say, well, I did a lab test, I got that number, I fed it into a stability analysis, the factor safety is 1.635. I said, yeah, but what about all the other things? What about when you do a sample, that's just one sample out of a very complex foundation, for example, and think different materials behave differently in one sample. That's not enough. But it's really that thinking process. I have some examples of what's not written in textbooks and faced as an engineer, what you may have to do. I had a case on a project where I was asked to advise whether or not they could put a groundwater well in and get a water supply for the crusher, which was up in the mine area. And I said, I'm not sure. I looked at it and said, okay, I think you can. If you put a well in there, you can get let's just say 100 gallons a minute, and that's enough for it. And they said, what do you mean there's no water? We have a report this thick that says we have to have a dewatering system in the mine of 10,000 gallons a minute. And I said, no, you don't. And they said, how do you know? I said, well, it only rains so much. You're on top of a mountain. You only have so much water. So how can you, if you have that amount of water in, you can't have 10,000 gallons a minute going out. So people get so buried in models that they can't just see the big picture and say, well, actually, no, that doesn't make any sense. And likewise, today we're going through all these dam break analysis where people are just assuming that the dam fails and disappears and everything flows like a phase shower or fundal. But you have to think about no, that can't happen physically. So I think it's these lessons where you have to think about something and say, well, does that make sense?